Okay, so we'll start recording.
Alright.
3, 2, 1. Hi!
Welcome to Beards and Beers, and today we have a very special guest. He stunned the industry in July when he announced that he was bringing his talents to the Oracle Labs to continue his work on the Micronaut framework, as well as branch out on other technologies in the Oracle stack like Graal VM and the Helidon framework. I'm very thrilled to have him on the show and can't wait to dig into some questions. So let's welcome him. Welcome, Graeme Rocher. Welcome, Graeme.
Hi, good to be here.
We appreciate you joining us here, and G and I have tons of questions for you. Beards are of course not mandatory, and neither are beers. But G and I have ours. But we do thank you for joining. We have tons of questions for you, so let's jump right into it. So first question, and G, anything to add there, buddy?
No. I'm really excited of having Graeme here.
Excellent. So Graeme, you are an architect, you're a software engineer, you're a husband, you're a father, community leader, you're a speaker, framework author, Java champion. You have all kinds of these titles, things that people call you. But in your words, Graeme, who is Graeme Rocher?
Been in the Java space for a very long time, and worked at some very interesting companies, founded my own company, and worked with different languages. And I think what I'm really about is continually exploring of pushing improvements and making things simpler. So many technologies are just I'm allergic to complexity, right? I find when things are complex, it's this is just painful. So I look for ways to make things simple for the developers, and that started with Grails and continues with Micronauts, and I'm on a continued quest for simplicity, and that's what I try and do.
When I first started using Grails, to me, it's funny that you said those specific words, because to me, I always felt like from the very beginning of using it, I always felt like Grails was invented by somebody who had solved difficult problems before and wanted to make them easy to solve in the future for other people. It's hard to really nail down the specifics of why I felt that way, but it was something that I got from the Grails framework that I never got from any other framework that I had worked with. It was a framework solved out of pain almost, or created out of pain almost. You know what I mean? Like, these are some painful problems, not painful, but redundant, boring, verbose things that we have to do as developers. Let's make it easy for them. So I will say that, like I said, it's funny to hear you say those things, because it's very obvious to me, based on your work, that those things definitely ring true.
But let's get into the inspirational part, because Graeme, you've built a successful Java-based framework for traditional applications. That was Grails, at least the intention. So I guess that Micronaut was the natural move to the next step, microservices. I'm wondering, what were the challenges you faced when defining the new framework? What were you looking after, and what you trying to solve with this new microservice world that we are living on?
Grails was built a long time ago, and it was the first release 13 years ago or more from that. And architectures back then were very, very different in terms of how people built applications, and really everybody kind of deployed their application to a servlet container. And the servlet container had a fair amount of opportunity to, or the Java EE container, or whatever you want to call it, had a fair amount of opportunity to share resources amongst applications and optimize memory across. Maybe you have 5 Grails applications deployed, and they could share memory. But as soon as everybody started deploying applications with an embedded container, which was really started by Spring Boot and then Grails as well, the memory requirements for running something like Grails and Spring Boot were prohibitive for certain use cases, mainly serverless, and in particular microservices. I was looking at some of the architectures that were coming out in some of the other languages, and like things like Golang, for example, where you can essentially run a cluster of microservices, and each one is only occupying a fraction of memory and really optimizing resources. Now you try and replicate that same architecture with Java, right? You eat a lot of memory if you use a framework like Spring Boot or a framework like Grails, where each application is running in a container with its own JVM and so forth. So I think, I looked at those kind of stacks and like alternative languages, and I think we have a lot to learn in the Java space about being more efficient. People tend to create a lot of waste in the Java language. And a lot of the reason for that is the way that all the tools have been designed around reflection, around things like runtime bytecode generation. Generating bytecode at runtime eats memory. Has a cost at startup. And I wanted to see if we could build a framework that was efficient from a memory and startup performance perspective, but still had the same like productivity benefits that you get from the Spring Boots, from the Grails of this world. And that's when we started Micronaut back in 2017 as a kind of research project to see what we could do.
Yeah, usually there are some trade-offs, right? If you want to get lightweight framework and that performs really well, there are some things that you need to sacrifice there.
Yeah, absolutely. I mean, in terms of, but that's the thing with Micronaut. I didn't want to make any sacrifices.
You wanted it all, right?
You wanted it all.
The best of all worlds. Like let's get performance and let's get it easy to use and no trade-offs, no sacrifices. Right. So I think you've done that, because I'm a long-time Micronaut user. I've got my Micronaut gear on.
So I mean, to be fair, there is a sacrifice. There's always a sacrifice, and the sacrifice is compilation speed, right? Because we compute everything ahead of time,
right,
doing compilation.
But that's a sacrifice I think a lot of developers are willing to make for runtime performance, don't you?
Developers are willing to sacrifice compilation speed for productivity, and you see
True.
That, as well as runtime performance and productivity. At the same time, you cannot have something that is like really adds significant overhead into a project, and that's where I think architecturally with Micronaut, using annotation processes, we were able to achieve things like incremental annotation processing and incremental compilation. And that's really important, right? Because if you're going to add overhead to the compiler, you at least need, when you make a change, to have support for incremental compilation, such that a small change doesn't result in recompiling the whole code base. And that's one of the things you have to be really aware of when you're looking into compilers and so forth. You want to achieve incremental compilation, and we did with Micronauts. We have really nice incremental compilations.
If I'm not mistaken, Micronaut was one of the first frameworks to really do any of this ahead of time compilation, especially when it comes to annotation, using annotation metadata, as you've just explained. How does it feel to have kind of inspired really the whole Java community with that? And you've really kind of, I mean, you have entire teams at very large companies right now trying to basically, and recreating what you've done with Micronaut with other frameworks. How does it feel to have kind of inspired this really movement in the entire community?
I think it's great validation of that what you're doing is the right path and the way forward.
We appreciate you joining us today, Graeme, and stick around and join us for our next episode. We're going to get a little deeper with Graeme and talk a little bit more about Micronaut and some of the other things he has going on. So thanks a lot, Graeme.
Thanks very much.